Ladies and gentlemen, welcome to what we like to affectionately call the extension of geometry's most elegant theorem. Quick little lesson, part 2 of the Pythagorean theorem. We're going to extend that a little bit. It's called Theorem 70 in the book. Remember, the number means nothing, but that's what it is. And then there's going to be a little piece we're going to chat about quickly called the extension of Theorem 70. So, into your notes, first of all, I draw this triangle right here, triangle leg. And what you're going to see is this side of the triangle. I don't know it's the hypotenuse yet because I don't know it's a right triangle. But this side is C. This length over here is A. And this length over here is B. So here's the wording, Theorem 70. If the square of the measure of one side of a triangle, I'm going to take C arbitrarily. It can be anything. When I square that, here's what you get, 207.92, wonderful, whatever. If that square is equal to the sum of the squares of the measure of the other two sides. So if I took C out of the equation, now I'm looking at A and B. That's the other two sides. So if I sum them, if I add them, if I take the sum of those two things, but I square A and I square B and I add them, check out what you get. Well, you get 207.92 as well. It says this, though. Let's keep going. If the square of the measure of one side of a triangle, check, is equal to the sum of the squares of the measures of the other two sides. Check. So these guys, if I could do it, I can. They are equal to each other. If that's the case, then what this theorem says, then the angle opposite the longest side is a right angle. What's the longest side? Well, let me take away the sides, and here you go. What you're looking at is C happens to be the longest side. So this theorem says across from the longest side, that angle right there happens to be, yepper, a right angle. So it's just kind of an extension of the Pythagorean theorem, which we kind of know, but there's a little bit more to extending the Pythagorean theorem other than Theorem 70. So that's the idea, though. It's pretty cool. Let's go to the next thing so you see the actual extension. What I would do is write this in your notes, and you're going to have three scenarios. This is scenario A. It says if C, this is important, if C is the longest side of the triangle. Now, it can be anything, but in this picture, we're saying C is the longest side. So if it is, and we have the sum of A squared and B squared, something's going to happen here with the relationship amongst that sum, and just the longest side squared. Take a look at what's happening here. If I have A squared and B squared, and I add them together, the sum in this example, you see, is exactly equal to C squared. So you see that this 57.83 is exactly this 57.83. And you notice this is the scoop. These guys are equal. So you see, no pun intended, across from the C is my 90-degree angle. So you know this, though. You can see it right here, too. There's your 90-degree angle. You can see exactly that angle dog is 90 degrees. So this is scenario A. Anytime you have A squared plus B squared equaling C squared, I know you all know this because it's the Pythagorean theorem, this is a right triangle. Lovely. So that is part A of this extension. Let's go on, though, and do part B, and you'll see what happens here with it. Let me do this. I'm going to take this point, and now I'm going to make these things not equal to each other. I'm actually going to do this. I'll make it smaller. So there, I'll pull it in like that. So what you see now is this. You see that this particular sum, the sum of these two things right here, is 44.24. And C squared, the longest side of the triangle, is 50.63. So what relationship you see here is the sum is actually less than. The sum is actually strictly less than C squared. So up here, the sum is less than. Well, if that's the case, if A squared plus B squared is less than C squared, what happens? What kind of triangle is this thing? Well, let's take a look at the angle measures. One angle is an acute angle. Second angle is an acute angle. Oh, looky there. The third angle is an obtuse angle. So what you're seeing is one simple example. No, I'll show you a couple other ones, but one simple example where anytime you have the sum of the A and B squared, where C is the longest side, and it's strictly less than, that sum is less than just C squared, it is always, always, always an obtuse triangle. So that is part B of the extension of Theorem 70. And I'll show you another example, because watch. Let's see. Let me move this down. So if I move this guy down, so what you're looking at now is this. It's a smaller triangle, doesn't really matter. But notice, the sum here is still, wait, sorry, messed up. Let me back up. Here we go. Yeah, I don't know, just move over here. It doesn't matter. You can't really see though if I do that. Yeah, whatever. It doesn't matter. You can see all this. So anytime I keep moving this around, you see this sum is less than that guy right there. And notice it stays strictly an obtuse triangle. So it doesn't matter where I move it as long as I have the sum. These all things are moving now. The sum of these two things, if it's less than c squared, it is going to be an obtuse triangle. So that's part B. Here comes part C. Let me reset this all. So back to the beginning. Here we go. So I'm back to a right triangle with a squared plus b squared equaling c squared. Let me make it a different way. Let me make it that the sum is actually bigger than. So let's keep on going with this. Let me see if I can do this. Whoops, let me get my point G here. Let me keep moving this. I'll keep moving that where the sum gets actually bigger than, there you go, there's an example. So you can see the sum right here, the sum is bigger of a squared plus b squared. It's bigger than c squared. I'll keep moving, it doesn't really matter, but if I keep moving it, oh, they're all going to move. Hold on. There we go. If I keep moving it, you can see the sum of the a squared plus b squared, it's bigger than c squared. Well, what's that mean in terms of a triangle? Well, here's the relationship. Again, I put this in your notes. This sum, a squared plus b squared, is strictly now bigger than c squared, as you see right there. What's the relationship? Well, what kind of a triangle does it make it if this relationship ever happens? Well, let's check out the triangles. Well, the angles of the triangle. You got that angle's obtuse, that angle's obtuse, that angle's obtuse. What did I just say? Not obtuse. Wow. That angle is acute. That's better. That angle's acute. Much better. And that angle's acute. Which means the triangle overall, you got it. That was silly. Is an acute triangle. So there is your relationship anytime that a squared plus b squared, the sum, where c is the longest side. You need to know that for sure. If the sum is bigger than c squared, it's acute. If it's less than, like the other example, it's obtuse. If it's exactly equal to, well, if it's exactly equal to it, then we know that's just straight up the Pythagorean theorem, so we know it's going to be a right triangle. So there we go. Now, I'm going to do one more thing for you for a summary. Here's how it all kind of comes together. When you look at the summary of this, the idea behind all this is kind of simple in this regard. I'd write this down too. So anytime you have a triangle, I don't care if it's a right triangle, obtuse triangle, or acute triangle, here's something that's really cool. If you notice a little relationship here, C in this picture right now in this triangle is the longest side. What I want you to notice is in this triangle, across from the longest side, over here, happens to actually be, comparing all three of these angles, DOG happens to be, angle DOG, happens to be the bigger angle. That's not a coincidence, guys. That happens every time. Check this out. Anytime you have the shortest side of a triangle, that shortest side right there is always and will always be opposite the smallest angle. And take a look. Angle DGO, that's this angle right there, is the smaller of the three. It happens every time. So my suggestion is I probably write that down. Let me change this up a little bit. I'll show you. Here, I'll move it like this. Whatever. So now, angle C, not angle C, side C, you see, is the shortest side. Well, is that across from the smallest angle? Well, let's take a look. DOG, check that out. It is the smallest angle. So there's your relationship. I'd write it down like this if you haven't already. The shortest side of any triangle is always across from the smallest angle in the triangle. Likewise, if you look at the longest side, here it is. The longest side happens to be this right here. The longest side of a triangle is always opposite the biggest angle in the triangle. And if you look, that right there is the biggest angle. Happens every time. So that right there, guys, is kind of your summary. So we're going to apply this in class. It's the extension of geometry's most elegant theorem, and we're going to have fun doing it. Rock and roll. We'll see you in class. Later. Peace.